Good evening to one and all. Today in this live lecture, we shall discuss the derivatives and integration of the transform. Actually, this is the lecture number 7, and now we shall discuss this part in this today's lecture. Here, up till we have studied the basic operational properties. Now we have to discuss the transform of a more complicated functions, but before that, we have to discuss the integration and derivative of the transform. See this, 1 minute. Okay, now this is the definition of the Laplace transformation which we have studied. These are the basic and typical properties of the Laplace transformation, a standard of typical functions. We have calculated the Laplace transformation. By using this typical function, we have to solve the number of problems based on this. Okay, now see this, Laplace transformation of sin at is equals to a divided by p square plus a square. Laplace transformation of cos at is equals to p divided by p square plus a square, because we have to solve the problems based on these properties. So I am going to revise this. Again, Laplace transformation of cosine hyperbolic of at is equals to p divided by p square minus a square, and Laplace transformation of a sine hyperbolic which is equals to a divided by p square minus a square. Okay, no problem. Now, derivative and integration of the transform. In the last lecture, we have seen theorem based on the Laplace transformation of the derivative. That means if f comma f dash comma f double dash dot 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 fn minus 1 are continuous function on t greater than or equals to 0, then its nth derivative fn is a piecewise continuous on t greater than or equals to 0 if for all the function e raised to c naught 0, then n is equals to 1, 2, 3 dot dot dot, then Laplace transformation of fn of t, which is given by p raised to n f of p minus p raised to n minus 1 f of 0 p raised to n minus 2 f dash of 0 p raised to n minus 3 f dash of 0. In this way we have proved this theorem also. Okay, now we shall discuss the next condition. What is that? Integration. Regarding the integration of the Laplace transformations here, see this, 1 minute. Now this is the definition regarding the Laplace transformation. Okay, now, yes, 1 minute. The Laplace transformation, f is piecewise continuous on t is greater than 0 of function o of e raised to c naught t, then the Laplace transformation of this integration over 0 to t f of u du, which is equals to f of p divided by capital F of p divided by capital P, where capital F of p is called the Laplace transformation of f of t. Okay, so in this way we can write the condition integration of that function. This is the proof. Already we have seen. Now we shall move towards the main theorem based on this, which is that theorems here. Now we have to discuss the main theorem. Theorem number 8. The function f is a continuous on t greater than or equals to 0 and is of o of e raised to c naught t, then Laplace transformation of t raised to n into f of t, which is equals to minus 1 raised to n fn of capital Fn of p. This is a very important relation for n is equals to 1, 2, 3 dot dot dot, in this way, where capital F of p is the Laplace transformation of small f of t. So this relation which we have to prove in this important theorem, this is called as a Laplace transformation or Laplace transform of multiplication by powers of I means here integers, t raised to 1, t raised to 2, t raised to 3, t raised to 4, dot, dot, dot in this integers. I mean here integers. So if we multiply by the integers, then Laplace transformation of t raised to n f of t is equals to minus 1 raised to n into capital Fn of p, which is equals to 1, 2, 3, dot, 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 where capital F of p is the Laplace transformation of small f of t. Now we shall prove this. Now we shall prove this theorem by the principle of method of induction. You know which type of a method of is called as a method of principal induction. If we have to prove, suppose we have to prove nth derivative of some particular function is a resultant function. Suppose we have to calculate the nth derivative of some particular function. Then to obtain the nth derivative, to obtain the nth process, we have to solve such all types of problems, or we have to prove all such types of theorems which are based on the induction method. Induction method means, first of all, we have to prove for n is equals to 1. Then we have to prove for n is equals to 2. In general, we have to prove for any value of n which is equals to m and m plus 1. Then we can generalize this for n is equals for any value of n. This process of proof or this process of solution to find the nth term, whatever may be nth derivative, then that method is called as a induction method. You know, lot of theorems we need to use method of induction to prove that theorem. See this. Now here in this case we have to prove theorem by the principle of a mathematical induction. Now we know that by the definition of the Laplace transformation, we know that L of small f of t, or which is equals to capital F of t, is equals to integral from 0 to infinity e raised to minus pt into f of t dt. Now differentiate this. Differentiating with respect to p. We have to differentiate this function with respect to p. So f dash of p on the left side, f dash of p, which is equals to on the right side d by dp, derivative with respect to p of all over integral function. We have to calculate the derivative on the integral function on the right side. That means we can take the integration. Actually, this is integration. See this. This integral is with respect to t. Note that. This integral is with respect to t, but we are differentiating with respect to p. So we can use this derivative in that integral. Okay? So we can take integral from 0 to infinity d by dp of e raised to minus pt into f of t dt. Now you know that if we differentiate this with respect to p, then there is only one function in the form of a p, e raised to minus pt. Regarding this f of t, see this, f of t is a constant. We have to consider constant when we are taking the derivative with respect to p. So keep this f of t as it is. We have to calculate the derivative of this function only. What is the derivative of e raised to x? जे स्टुडंट्स ऑनलाईन आहेत त्यांनी फर्स्ट आन्सर द्यायचं, म्हणजे मला लक्षात येतं की कोण कोण ऑनलाईन आहे, कोण कोण रेग्युलर म्हणजे अटेंड करतो ते. व्हॉट इज द डेरिव्हेटिव्ह ऑफ ई रेज टू एक्स? यू नो दॅट डेरिव्हेटिव्ह ऑफ ई रेज टू एक्स इज derivative of e raised to x is e raised to x, but derivative of e raised to kx is काय तो स्टुडंट, now you tell me answer. E raised to kx is e raised to kx into again derivative of kx is k. So we can write this in this way. So we can take the derivative e raised to minus pt. Okay, Silpa, शुभांगी दोघीच ऑनलाईन आहेत का? So we can take the derivative e raised to minus pt. So e raised to minus pt, derivative of e raised to minus pt with respect to p is e raised to minus pt into minus t, into minus t. Again derivative of the power, e raised to minus pt is a derivative e raised to minus e raised to minus pt into minus t, because derivative of p with respect to p is 1. So we can write this minus, keep this minus I, it is integral from 0 to infinity e raised to minus pt into t into f of t dt. So we can write according to the standard form of the Laplace property of a Laplace transform, we can write this as Laplace transformation of t into f of t. So we have to write, because here is a function t into f of t. So f dash of p is equals to, keep this minus I as it is, and the value of this function we can write according to the property of Laplace transformation, L of t into f of t. So now the final answer is L of t into f of t, which is equals to minus f capital F dash of p, or we can write here minus I as it is. So for the generalization, for the method of induction, we have to generalize this minus 1 as minus symbol. We can write minus 1 raised to 1, because we have to generalize, which proves the statement for n is equals to 1. What is the statement here? If we put in this statement n is equals to 1, then what will happen? L of t into f of t, which is equals to minus 1 raised to 1 into capital F dash of p. If we put n is equals to 1, and by procedure we will get this results here, we will get this result for n is equals to 1. If we put n is equals to 1 in the statement directly, then we will get minus 1 raised to 1 into capital F dash of p. Okay, now if we solve the first order derivative by using the Laplace transformation definition, then we get the same result, that is minus 1 raised to 1 f dash of p. This proves that result is true for n is equals to 1, because we have to use the method of induction here. So first of all we have to prove n is equals to 1. Similarly we have to prove for n is equals to 2, for n is equals to m, in this way. Now next here, if we consider any value as a m according to the method of induction, you can prove this. See this, you can prove for n is equals to 2. That means again you have to differentiate, you have to calculate the second order derivative. Then we will get the result, true result for n is equals to 2. Similarly, now we have to consider for any intermediate value, suppose n is equals to m, then what will happen? We have to replace n is equals to m in the statement of the theorem, that is Laplace transformation of t raised to m into f of t, which is equals to minus 1 raised to m into f n of p. So m means, actually see this, m means 1 2 3 4 dot dot dot, suppose m again dot 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 n. So m is any value of n we have to consider. Then now write down this Laplace transformation of t raised to m into f of t. According to the property or according to the definition, we can write Laplace transformation in the form of an integral, that is integral from 0 to infinity e raised to minus pt t raised to m f of t into dt, and keep this right side as it is. There is no any problem on the right side. Now we have to differentiate with respect to p again, means derivative with respect to p on left side. See this, derivative with respect to p on the left side, keep left side as it is by taking the derivative with respect to p. But on the right side, what will happen here? This is a constant position, minus 1 raised to m. Keep this as it is. Now if we differentiate first time derivative after mth derivative, again we have to take the derivative after mth derivative, first derivative after mth derivative. So we will get m plus 1 the derivative of p. This is the on the right side. Okay. Now we have to solve this left side derivative. Now keep this derivative, take this derivative in the integral from 0 to infinity d by dp of e raised to minus pt, and remaining terms t keep as a constant coefficient. So again derivative of e raised to minus pt is what? Derivative of e raised to minus pt is minus t into e raised to minus pt, again t raised to m into f of t dt. On the right side is same term. Keep this minus on the brackets on outside of this integral. So minus integral from 0 to infinity e raised to minus pt into, again see this t, this t into t raised to m. By the rule of indices we can write t raised to m plus 1. Now we have to convert this. We have to convert this in the Laplace transformation. How we can convert this Laplace transformation, student? That is, keep this minus as it is. Now integral from 0 to infinity e raised to minus pt, t raised to m plus 1 into f of t dt. We have to use the Laplace transformation notation such as, see this, Laplace transformation of t raised to m plus 1 f of t, which is equals to same right side as it is. This shows that the result is true for any value of m. Any value of, if we consider n is equals to m, and if we differentiate this, then we get m plus 1. Same process. Then we get m plus 1. That means result is true for any value of m plus 1. This proves that the statement is true for n is equals to m plus 1. So by the mathematical induction, the statement is true for any value of n, and this proves that, or this shows that, hence proved. Hence proved. Which is the required proof? That means we can prove Laplace transformation of t raised to n into f of t, which is equals to minus 1 raised to n capital F n of p. So Laplace transform of t raised to n into f of t, which is equals to minus 1 raised to n capital F n of p. This is a very important result. That is a Laplace transform of multiplication by power of I. Okay? Do you understand this theorem? If you have any doubt, then you can ask. Doubt hai kare student? If you have any doubt, then you can ask me. कुठली स्टेप नाही लक्षात आली तर विचारा. Now we shall move towards the next important theorem. Theorem number 9. Laplace transform of division by t, or Laplace transformation of division by t. The statement of this theorem, see this. काय अडचण आहे का रे? कुणाला अगोदर विचारा, काय अडचण असेल तर आत्ताच विचारा, पुन्हा आपल्याला पुढे जायचं समजतं. Okay, now nine answer, yes, Pranoti Kadam. Okay, now see this theorem number 9. Laplace transform of division by t. If p is a piecewise continuous on t greater than or equals to 0 and is of order, see this, is of order pair. Okay, or we can write exponential order O of e raised to c naught t, and f of t has a Laplace transformation, then prove that, then we have to prove Laplace transformation of small f of t divided by t, which is equals to integral from 0 to infinity capital F of u du. Capital F of u du, where capital F of p is a Laplace transformation of small f of t dt. Laplace transformation of small f of t dt. Okay, now see this. You know that according to the definition of the Laplace transformation, L of f of t is equals to, we can denote this as a capital F of p, which is equals to integral from 0 to infinity e raised to minus pt into f of t dt. This is the standard definition of the Laplace transformation. You know all these things. Now we have to replace p by u and integrating on both sides. If we replace p by u and integrating on both sides, suppose this is a p is replaced by u, keep this as it is, there is no any change. Capital F of p we can write capital F of u, then on the right side e raised to minus pt, we have to replace p as u, replacing p as u and integrating on both sides from 0 to infinity. Now we have to integrate this f of u with respect to u. So integral from 0 to infinity capital F of u du, which is equals to integral from 0 to infinity integral from p to infinity e raised to minus ut dt du. Okay, now see this. 1 minute. What is the result which we have to prove? Actually, we have to prove the Laplace transformation of, the result is 1 minute. Laplace transformation, we have to prove integral from 0 to infinity f of p to infinity fu. Now, okay, 1 minute. So we have to calculate the Laplace transformation of p to, see this, p to infinity capital F of u du. We have to prove this result. Check this. So we have to take the integrating on both sides from p to infinity. So we have to write this as a p. P to infinity capital. See this, consider this 0. There is no any 0. P to infinity, because we have to calculate this value. So integral from p to infinity capital F of u du, because see this, we have to prove this result, integral from p to infinity capital F of u du. So we have to take the integrating from p to infinity, and in that integration also we have to consider p to infinity. Keep this integral as it is, 0 to infinity. Take this two integral from p to infinity as it is with respect to u on both sides, with respect to u. So again these two, this function f of t is constant regarding u with respect to u. So keep this constant coefficient f of t and dt as it is. Now take the integral p to infinity e raised to minus ut du. Integration from p to infinity e raised to minus ut du. Now check this, student. P. Now check this. Now we have to take the integration of this part only, interior part. Integral from 0 to infinity e raised to ut du. We have to calculate this part only. We have to solve this inner capital bracket. What is the integration of e raised to minus ut with respect to u? Who can tell me, student? The students who are attending this lecture online, you have to tell me what is the integration of e raised to minus ut with respect to u. So integral from p to infinity. So you have to again write here p, 0 to infinity. So we can write integral from p to infinity e raised to minus ut du, that will be e raised to minus ut divided by, again derivative of that power is minus t, and keep the lower limit of integral is p, upper limit of integral is infinity. Lower limit of p and upper limit is infinity. Now if we put upper limit, so e raised to minus ut, this is the integration with respect to u. So these limits are for u. That means we have to keep lower limit p in place of u, upper limit in place of infinity. So, शिल्पा पांचाल e raised to minus ut upon minus u नहीं है, minus u नहीं, derivative of integration with respect to u. So divide by derivative of that index. Ut is a derivative with respect to u is minus t. So here is a minus t. Check this, minus t है तो denominator मध्ये. Now keep this upper limit and lower limit. E raised to minus infinity we have calculated number of times. So value of upper limit is 0 plus value of lower limit is p. So e raised to minus pt, e raised to minus pt divided by t, and this minus minus here, see this denominator's minus is plus. So the value of inner integral or this capital bracket is, see this value of this capital bracket is e raised to minus pt upon t. So put this value e raised to minus pt upon t in this equation 1. Put in equation 1, then our integral becomes, how we can write, see this, integral from p to infinity capital F of u du, which is equals to integral from 0 to infinity. The value of interior integral, inner integral, capital bracket, is e raised to minus pt upon t into f of t dt. So take this here, integral from 0 to infinity e raised to minus pt into this t is in the form of 1 upon t f of t dt. So we can use the property of a Laplace transformation. Okay, Manisha Rathod, Pranita Misal, Rathod Sangeeta, Pranavati Kadam, Panchal, भंडे, ओके ठीक आहे. एवढेच आहेत का रे, बाकी ऑनलाईन नाहीत का? 10-12 ऑनलाईन आहेत का? मी अटेंडन्स यांची घेतो पा, तुम्हाला जे अब्सेंट आहेत त्यांना एक्झामला नाही बसू दिलं जाणार पा. ओके, now so we can write this as a Laplace transformation of f of t divided by t. Hence we have proved the result, Laplace transformation of f of t divided by t, which is equals to integral from 0 to infinity f of capital F of u du, and hence proved. This is the second important theorem which we have proved. Okay, see this. लक्षात येतं का? याच्यात काय अडचण आहे का? कुणाला विचारा. इफ यू हॅव एनी डाऊट, चला रे, कुणाला डाऊट आहे का विचारा. डाउट है का? We have to prove Laplace transformation of f of t divided by t is equals to integral from p to infinity capital F of u du. Okay, if you have any doubt, then you can ask in college also, in the department, whatever. If you have any doubt, कुठल्याही विद्यार्थ्यांना जर तुम्हाला कुठलाही डाऊट आला तर तुम्ही स्वतः येऊन डिपार्टमेंटला विचारा, नोटबुक घेऊन या, मी तुम्हाला ते परत एकदा एक्सप्लेन करेन चांगल्या पद्धतीने. ठीक आहे. नाउ नेक्स्ट वी हॅव टू सॉल्व द प्रॉब्लेम्स बेस्ड ऑन दिस. इव्हॅल्युएट द लॅपलास ट्रान्सफॉर्मेशन ऑफ द फंक्शन f of t which is equals to e raised to 4t into cos h 5t, means hyperbolic cosine 5t. Here function is a cosine hyperbolic of 5t, and e raised to 4t into cos hyperbolic 5t. Now solution, see this Laplace transformation of, we know that according to the Laplace transformation of some standard function, you know the formula, Laplace transformation of cos h AT. You know that. What is the Laplace transformation of cos hyperbolic AT? Already we have seen that formula is P divided by P square minus A square. Already we have proved this formula. See this. Cosine of hyperbolic of AT. Already we have seen. 1 minute. Cosine of hyperbolic AT. We can write P divided by P square minus A square. First of all, we have to, in this problem, we have to calculate the Laplace transformation of cosine hyperbolic of phi t according to the standard form. So we know that the Laplace transformation of First of all, we have to calculate the Laplace transformation of cosine hyperbolic of phi t. That means according to the formula, Laplace transform of cosine hyperbolic AT, which is equals to P divided by P square minus A square. Here A means considered as a phi. So P divided by P square minus A square means phi square. P divided by P square minus 25. Suppose this function is considered as a capital F of P. You know that. We can write Laplace transformation of this. Consider capital F of P. Okay. So Laplace transformation of cosine hyperbolic phi t is P divided by P square minus 25, and consider this P divided by P square minus 25 is capital F of P. Okay. समझते हैं ना? Now, by the shifting theorem, now we have to use the shifting theorem. What is that shifting theorem? L of e raised to 4t cos h phi t. See this again. L of e raised to 4t cos h phi t. You can write capital F of P minus 4. This is a shifting theorem. This is shifting theorem. Already you have seen this shifting theorem. First shifting theorem. Laplace transformation of first shifting theorem. That means suppose this is e raised to at. Suppose this is a. Then we have to write P minus a. We have to write P minus a. समझते का पहा. See this, Laplace transformation of e raised to at into f of t. We can write capital F of P minus a. First shifting theorem, e raised to at, where here capital F of P is Laplace transformation of small f of t. So, according to this first shifting theorem, we can write this e raised to 4t cos h phi t is equals to f of P minus 4. But you know that f of P is equals to, capital F of P is equals to, we have considered capital F of P means P divided by P square minus 25. So capital F of P means P divided by P square minus 25. But we have to calculate capital F of P minus 4. So in this relation we can write capital F of P minus 4, which will be P minus 4 divided by P minus 4 bracket square minus 25. That means we have to write in place of P as a P minus 4. So we get this result, P minus 4 divided by P minus 4 bracket square minus 25. So P minus 4. According to the expansion, A minus B bracket square, A square minus 2AB plus B square minus 25. So which will be the final result, P minus 4 divided by P square minus 8P, 16 minus 25 So we will get p square minus 8p minus 9. Okay? So hence the Laplace transformation of e raised to 4t into cos h phi ut, we can write p minus 4 divided by p square minus 8p minus 9. Do you understand this? ये आपको समझ में आया क्या स्टूडेंट्स? समझ में आया क्या? डू यू अंडरस्टँड? सर्वांना प्रॉब्लेम समजला का रे? हा प्रॉब्लेम ओके, तुम्ही नंतर लिहून घ्या, अगोदर फक्त समजून घ्या. Same, now we have to solve second problem. Which is that second problem? Capital F of t is equals to e raised to minus t into 3 cos 60 minus 5 sin 60. Okay? Now, again, see here. We have to find out the Laplace transformation of this combination function, multiplicative function e raised to minus t into 3 cos 60 minus 5 sin 60. But we know that the standard form for the Laplace transformation, we know that the Laplace transformation of sin 80. There is also standard form of Laplace transformation of cos 80. So first of all, we have to use the Laplace transformation for 3 into cos 60, 5 into sin 60. That means we have to calculate Laplace transformation of this function first of all. And then by using a first shifting theorem, we have to calculate the Laplace transformation of multiplicative function e raised to minus t or the combination of the e raised to minus t. So we consider first of all this function. We have Laplace transformation of 3 into cos 60 minus 5 into sin 60. Keep this constant coefficient 3 as it is. Laplace transformation 3 into Laplace transform of cos 60 minus 5 into Laplace transform of sin 60. According to the definition, you know that Laplace transform of cos 80. Who can tell me what is the formula for Laplace transform of cos 80? The students who are attending this online lecture, now you tell me please, what is the Laplace transform of cos 80? Again you have to write Laplace transform of sin 80. Formula you know that Laplace transform of a cos 80, which is equals to p divided by p square plus a square. Here a means 6, so a square is 36. Very good, Pranali Patil. Similarly, Laplace transform of sin 80, थोड़ा फर्क है, पास see this. Laplace transform of sin 80. अगर यहाँ पे sin होता है ना, then we have to write a divided by p square plus a square. This is the main difference. For cosine function, we have to write p divided by a p square plus a square. For sine function, you have to write a divided by p square plus a square. This is the main difference between Laplace transform of sin 80 and cos 80. So we can write this p divided by p square plus 36, and Laplace transform of sin 60 is equals to 6 divided by p square plus 36. So again 3p divided by p square plus 36 minus 30. 5 into 6 means 30 divided by p square plus 36. So denominators are same. So the addition of these rational algebraic expressions are 3p minus 30 divided by p square plus 36. Suppose this all function we have to consider as a capital F of p. Now this we have to consider capital F of p. Then we have to calculate the Laplace transform of this. Again, you know that by the first shifting theorem, how we can write for the Laplace transformation according to the first shifting theorem, we can write suppose e raised to minus 80. तुमच्याकडे असेल तर पाहतो मी फर्स्ट शिफ्टिंग थेरम. तो फर्स्ट शिफ्टिंग थेरम वापरा e raised to 80. हा जो आहे ना तो थेरम वापरा, म्हणजे काय येईल पहा, f of t. So we can write this as capital F of Laplace transform of e raised to at into f of t, which is equals to f of p minus a. So according to this first shifting theorem, we have to consider this. Now, by the first shifting property or theorem, Laplace transform of e raised to minus at into f of p, so f of t, which is equals to f of p plus 1. हाँ, स्टूडेंट इथं सांगा बरं ए ची व्हॅल्यू काय? ए ची व्हॅल्यू Laplace transform of e raised to at into f of t. Here a is minus 1, f of p minus 1, p minus a, but a is minus 1 in this problem, so minus minus plus 1, so we will get the result capital F of p plus 1. Now again here it is very important to shifting this function. How to shift this function? We have to shift this function according to this supposition. Capital F of p means 3p minus 30 divided by p square plus 36, means according to the our supposition capital F of p, which is equals to 3p minus 30 divided by again p square plus 36. But we have to calculate capital F of p plus 1. That means we have to shift, we have to write p as a p plus 1. So capital F of p plus 1, which will be the result 3 into p plus 1 minus 30 divided by p plus 1 bracket square plus 36. So, and calculate this, you will get the particular solution, perfect solution. ओके, समजतं का रे प्रॉब्लेम? फक्त नंतर कॅल्क्युलेट करा, कॅल्क्युलेशन आहे. यू हॅव टू राइट द expansion formula for the function p plus 1 bracket square p square plus 2p plus 1 plus 36. So 3p plus 3 minus 30, that will be 3p minus 27. So p square plus 2p plus 37. Okay, Pranali Patil, right? So we will get the result. This is the Laplace transformation of this combination function. Do you understand this? Okay, समजतंय ना तुम्हाला? Same problem. Again we have to move towards next problem. आता थोडं फास्ट जाऊ. Again we have to calculate the, don't write. तुम्ही माझ्यासोबत लिहून घेऊ नका, फक्त समजून घ्या. You have to write after the completion of the lecture. Okay, you have to revise that lecture and then write down. Now see this, we have to calculate the Laplace transformation of f of t is equals to 3 into t raised to 4 into e raised to 5t. But we know that the Laplace transformation of t raised to n, Laplace transformation of t raised to n, we have already proved one theorem. So consider this function first. Laplace transformation of 3 into t raised to 4, which is equals to 3 into Laplace transformation of t raised to 4. And Laplace transform, you know that Laplace transformation of t raised to n, which will be the n factorial divided by p raised to n plus 1. You know, already we have proved this theorem. So t raised to 4 divided is equals to 4 factorial divided by p raised to 4 plus 1. Is it okay? So 4 factorial means that gives a value 24. Divided by 4 plus 1 means p raised to 5. 72 divided by p raised to 5. So consider this function as a capital F of p. This is our supposition, first supposition, because we have to use the Laplace transformation for the first shifting theorem. Now, by the first shifting theorem, Laplace transformation of e raised 3 into t raised to 4 e raised to 5t. Here in this case a is 5 because Laplace transformation of e raised to at f of t dt, f of t which is equals to capital F of p minus 1. इथं a म्हणजे p minus a, सॉरी a म्हणजे किती आहे रे स्टुडंट या ठिकाणी? ओके, a means 5, e raised to 8, a means 5, so capital F of p minus 5, so we can write 72 divided by p raised to 5, f of p means 72 divided by p raised to 5, that means f of p minus 5 means 72 divided by p minus 5 bracket raised to 5. This is our final answer. Okay, now we can solve this alternating method also. First of all, calculate Laplace transformation of 3 into e raised to 5t. असं सुद्धा कन्सिडर करता येतं. First of all, you have to calculate the Laplace transformation of e raised to 5t, and then you can calculate this by using nth order derivative function. You can calculate also this, but okay, there is no problem. Now next we shall move towards the next problem, problem number 4. Laplace transform of e2 into e raised to minus 2t into cos square 3t. Actually, we have to solve this problem. This is a problem number 4. We have to calculate the Laplace transform of f of t is equals to 2 into e raised to minus 2t cos square 2t. But student, you know that there is a standard formula for Laplace transform of cos at. Laplace transform of cos at, though there is no any standard formula for Laplace transform of cos square at. So we have to use a formula. What is that formula? 1 plus cos 2 theta is equals to 2 into cos square theta. You know that this is the trigonometric identity. This is a trigonometric identity. Why we have to, what is the necessity of use this formula here? First of all, you tell me why we have to use this formula. What is the necessity to use this formula here in this case? Because here there is no any direct formula for the Laplace transformation of cos square at. This is a cos square at, because we have a formula for Laplace transform of cos at. So we have to reduce this square by using the trigonometric identity. So we can write this cos square at, cos square theta, we can write 1 plus cos 2 theta divided by 2, or 2 cos square theta is equals to 1 plus cos 2 theta. That means by using this trigonometric identity, we can remove the cos square. So this cos square we can remove. Cos square 2 into cos square 3t, combine formula this. Keep this 2 and cos square 3t here. So 2 into cos square 3t यानी कि Laplace transformation 1 plus cos 60 by using this formula. This is the identity. Now separate this Laplace transform. Laplace transform of 1 plus Laplace transformation of cos 60. Again Laplace transform of 1. Already we have the standard formula for the Laplace transform of 1 is 1 upon p. Similarly, the Laplace transformation of, okay, Pranali Patil, very nice. Laplace transform of cos 60, according to the Laplace transform of cos 80, p divided by p square plus a square, but a is a 6. So again consider this as a capital F of p. Now by using the first shifting property, again you have to use the first shifting property. Laplace transform of 2 into e raised to minus 2t into cos square 3t, which is equals to f of p plus 2. हा इथं सांगा बरं, आता इथं ए म्हणजे किती आहे? इथं या कंडिशन मध्ये आता हे तर 2 बाजूला आहे, पण इथं लॅपलास ट्रान्सफॉर्मेशन अकॉर्डिंग टू द फर्स्ट शिफ्टिंग प्रॉपर्टी. Suppose this is small f of t means 2 into cos square 3t. So Laplace transform of e raised to at into f of t. So in this case a is equals to minus 2. A is equals to minus 2. So f of p minus a means p plus 2. Again, now see here, f of p means what? F of p means 1 upon p plus p divided by p square plus 36. So we have to calculate f of p plus 2. So we can write this p here. 1 minute. 1 upon p plus 2. Again p plus 2. Again p plus 2 bracket square plus 36. Now this is our Laplace transform of this function is this. Now our aim is to solve, simplify this function only. That is 1 upon p plus 2 plus p plus 2 divided by p plus 2 bracket square plus 36. Now use a plus b bracket square expansion formula. So it will be 1 upon p plus 2 plus p plus 2 divided by p square plus 4p plus 40. 40, how plus 4 plus 36 means 40. Now take LCM again, then this is our final result. This is our final result for the Laplace transformation. ओके, तर अशा पद्धतीने हे प्रॉब्लेम्स आहेत. आता उद्याला परत याच्यावरचे. नाउ इफ यू हॅव एनी डाउट देन यू कॅन आस्क मी रिगार्डिंग द सोल्युशन ऑफ द प्रॉब्लेम्स, because you have to solve Laplace transformation of this combination of the problems by using the properties and first shifting property, first shifting theorem. ओके, तर काही अडचण आहे का? कुणाला काही विचारा. अडचण असेल तर तुम्ही मला सॉल्व करून सांगा. मी तुम्हाला या बेस्ड काही होमवर्क देतो. होमवर्क तुम्ही करायचंय, सोबत सोबत होमवर्क सुद्धा पाठवायचंय. ठीक आहे, 1 मिनिट. तर मी इथं होमवर्क लिहितो. You have to write the Laplace transformation of first Laplace transformation of e raised to 4t into cos. Write down this homework. Cos hyperbolic 7t. Second problem, Laplace transform of e raised to minus 5t into sin 16. Is it possible to solve these problems for you, sir, students? Okay. Now third, Laplace transform of 2 into e raised to 2t into cos square 4t. Okay, again we shall write the Laplace transform of shifting power 4 Laplace transform of t raised to 5 into e raised to minus 3t. Okay, now you have to solve these 4 problems in your homework. In addition, I shall give another problem, that is 5 Laplace transform of 1 minute. Laplace transform of e raised to fifth problem. Laplace transform of e raised to t into cos square t. 1 minute. Cos square t. And 6 एक इंटरेस्टिंग प्रॉब्लेम देतो. You have to think about the particular formula. This is a very interesting problem. Laplace transform of sin 2t into sin 3t. You have to think about the formula for this. Actually, you have to use defactorization formula here. And then sin 2 into sin A, sin B. In this way, you have to use the defactorization formula here. Then it is possible to solve the sixth problem. सोडवता का रे problem? ओके का हा यस नो प्रॉब्लेम, काही अडचण नाही आहे, तुम्ही कसंही सॉल्व करू शकता. ओके, तर हे 6 प्रॉब्लेम सॉल्व करा. प्रणाली पाटील, काही अडचण नाही, तुम्हाला ज्या पद्धतीने इझी होतं त्या पद्धतीने सॉल्व करा. तर अशा पद्धतीने इथं आपण थांबू. तुम्हाला काय अडचण आली तर विचारा, त्या पद्धतीने तुम्ही हे सॉल्व करू. उद्याला आणखी याच्यावरचे डेरिव्हेटिव्हचे प्रॉब्लेम्स आहेत ते उद्याला घेऊ. इथं थांबू. तुम्हाला काही जर आलं तर विचारा. यस यस, तीच मेथड यूज केलेली आहे प्रणाली पाटील. आपण सुरुवातीला कॅपिटल एफ ऑफ पी कॅल्क्युलेट केलेला आहे आणि त्याच्यानंतर लॅपलास ट्रान्सफॉर्मेशन ऑफ ई रेज टू ए टी इंटू एफ ऑफ पी कॅल्क्युलेट केलेला आहे. तो म्हणजे फर्स्ट शिफ्टिंग प्रॉपर्टी. अगोदर एफ ऑफ पीच काढावं लागेल आणि नंतर फर्स्ट शिफ्टिंग प्रॉपर्टी वापरावं लागेल. डायरेक्टली सुरुवातीला फर्स्ट शिफ्टिंग प्रॉपर्टी वी कांट यूज. ठीक आहे, तर काय अडचण आली तर विचारा. काही प्रॉब्लेम आहे का आणखी? राजमाने, संभाजी राजमाने, कदम, शिल्पा पंचाळ. ओके, तर ठीक आहे. हे 6 प्रॉब्लेम आणि सर्वांनी असाइनमेंट्स पाठवा, ग्रुपवर पाठवा. हे प्रॉब्लेम सॉल्व करूनच पाठवा प्रत्येकाने. ठीक आहे. ओके, नाउ वी शॅल स्टॉप हिअर. गुड नाईट.